cyclic chirality, please refer to those videos, and also you refer to those videos specially because I have already discussed chemistry of carbohydrate over there. Okay, now it is chemistry of biomolecule. Mainly we will cover the DNA. Okay, the DNA and RNA. So as you know that DNA is made up of, if you see, this is a double helical structure of DNA. This strand, okay, I have separately mentioned over here. And the secondary structure, the helical structure of DNA, greatly depends upon the number of hydrogen bonds between these two base pairs, okay, of DNA. So that's why you can see that, you know, some books they do like this. Okay, this is the hydrogen bonding, and without that hydrogen bonding, a DNA cannot be double helicals. Okay, that is the secondary structure. So now DNA mainly made up of nucleotides. What is nucleotides? So nucleotides. Now, if you see the nucleotides consist of one base pair, okay, on base, sorry, nitrogenous base, okay, then a ribose sugar and a phosphate, you know, functional group. And if you see the next nucleotide is attached to the first nucleotide with the help of a phosphodiester, phosphodiester bond. It's very important. In our coming pharmacology video, we'll be having phosphodiesterase enzyme, okay, which hydrolyze this particular ester bond. So that we'll be discussing eventually. So now this is nucleotide. If you remove this phosphate group of DNA nucleotide, the nucleotides become nucleosides. Okay. So I'll just explain that nucleotides are organic molecule consisting of a nucleoside and phosphate group. Okay. Nucleosides are N-glycosides of nitrogen base. So why it is N-glycoside? Because the sugar molecule, the ribose sugar, you know, we'll be making our video on biochemistry on pentose phosphate pathway. Okay, those pathway is very useful to, you know, to yield ribose, because without the ribose DNA cannot be synthesized in our body. Okay, now the glycoside is formed between this anomeric carbon, the anomeric carbon of sugar, okay, anomeric carbon of sugar backbone, which is, if you see the length of 9th position of this sugar, this base with the sugar molecule. So 9th position, why? Because this is the numbering which is given in a standard book for the biochemistry. Okay, so this is the glycoside bond takes place between the ribose sugar and the DNA base. Okay, this base is known as purine. Purine, the two ring combining pyrimidine and imidazole. These two ring should be fused, okay, to give the structure of purine. Now you have two purine base, one is guanine, one is adenine. Okay, and pyrimidine base you have thymine, which is replaced in RNA by the uracil. Okay, uracil present in RNA, but in DNA thymine and cytosine, which is also pyrimidine base. Okay, now nucleotides get biosynthesized from the amino acids. So that's why in our cancer video we'll be discussing that if you increase the amino acid content in our body, your body grows, because it is not only protein, also DNA made up of by the the nucleotide which is supplied from the amino acid, especially the nitrogen base. Okay, now coming to the DNA structure, these are the structures. Especially we have this combination of A, T, C, G. So this, whatever it is, C, it is G, A, T, like that. DNA structure can be written. Now this is double helical structure. Now we will be making biotechnology video very soon, which actually tell you to how to determine DNA structure. This DNA structure determining, converting the double stranded DNA to the single stranded DNA, and then we will be going for analyzing the single stranded DNA. But as of now in body, the DNA, more we will be learning in the nucleoside video about the different type of DNA. We have Z DNA, B DNA, okay, different type of DNA. Now, after this DNA, that is known as, central dogma. Central dogma is nothing but DNA to mRNA, mRNA to protein. So DNA to mRNA, which is known as transcription. So what is the concept? When DNA getting formed to mRNA, mRNA is a single-stranded elements. It is not a double-stranded elements. Why? Because there is no double helical structure in RNA. Like if I give you some of the structure of RNA, U, G, U, G, G, then U, G, G, C, C, A, okay, C, C, A. I'll continue over here. This is the strand, okay. Then the last one, UJA. So now if you see, this is a single-stranded RNA is coming from the double-stranded DNA by the help of transcription. Now in the DNA we consider the individual base, okay, individually, the base individually, but over here in RNA we take 3 bases together, which is known as codon, okay. That's a very important concept. And you have AUG codon, which is known as starting or initiation codon, okay, which code for amino acid. Remember, we have total 64 codon. We have 64 number of codon which code for 20 amino acids, okay, in our body, okay. Now normally we have different type of amino acids, some essential amino acid I will be discussing very soon. Now coming to the codon, if you see AUG, it code for methionine, okay, it code for methionine. Then you have AUG, after that UGG. UGG will give you tryptophan. This is methionine, tryptophan, okay. Then CCA will produce proline, okay. And whenever this RNA